Hello and welcome to MySecretMathTutor. For this video, we're going to go over transformations of sine and cosine. So the big picture of this is that you essentially start with your basic graph of sine or cosine and you start to make some changes to it. And depending on what changes we make to the equation itself, it'll tell us how we've changed the graph of that function. So we're looking to read these key values that we see in the equation to figure out, well, how have they changed it? How have they stretched it out or maybe made it taller or shorter? And these values will give us all the information we need. Let's cover them one at a time to see what information they have for us and then get into some examples on actually using these things. All right? So the first value sits in front of our trigonometric function. Again, you want to think of this as sine or cosine. Could be either one. The information is going to be the same. So the a value here, or whatever number is sitting in front of us, gives us information about the amplitude. Now, I'm not saying that a is the amplitude. Usually we think of the absolute value of a, that being the amplitude. Let's go ahead and just mark this as absolute value of a. Other information it gives us is whether we should flip our graph over the x-axis or not. So let's say flip if a is negative. All right, on to our next value. B on the inside gives us information about the period. To find the period, you want to take 2 pi, that's the usual period of sine, and divide it by the absolute value of b. C is going to tell us how far left or right the graph has been shifted, so this is what we call the phase shift. To find the phase shift, we want to take C and divide it by B. So we'll get most of our information from C, but really don't forget to take this one and divide it by B to see properly how far left or right has gone. Also know that there's a negative sign in here, so if this value is already negative, then we're getting information of whether it shifted to the right. If this value is a positive value, then we have information of how it shifted off to the left. All right, on to D. D is for our vertical shift. So this is telling us how far up or down the graph has been moved, and this is just the value of D itself. All right, so now that we know a little bit about each of these parts, let's get into some examples and start reading these so we can go ahead and make a nice graph of one of our transformed functions. The first of these will be graphing y equals sine of 5x. And before we actually get into the graphing part, a good habit is to just keep the basic function of what sine looks like in the back of your mind. That way you can refer back to it and say, okay, if that's the original, what did they really changed? So in the original, we'd have an amplitude of 1, and we'd have a period of 2 pi. And of course, sine is that nice little S-shaped curve, looks like this. We'll only draw one period, but it does continue on in both directions. So I'm thinking about this basic shape as I go to make this one. All right, let's list out all of our values. A is the number that sits in front of our trigonometric function. In this case, it is 1. So we're going to use that to read our amplitude. We're thinking of the absolute value of A, or in this case, our amplitude is just 1. So it hasn't been stretched to make the peaks any taller or lower. On to B. B is the value that's sitting right next to our x, and in this case, it's 5. So that's going to give us information about the period. To find the period, remember, we're going to take 2 pi, divide it by the absolute value of 5. So we'll just get 2 pi over 5. This means that the usual graph cycles in a period of 2 pi. It goes through one complete period. Whereas ours, it's not going to take quite as long. It's going to go through that one complete period in only 2 pi over 5. All right, let's see what else we got. C and D. So C would be the number that's subtracted over here. There is none. And D would be any numbers added or subtracted to the outside. There is none of those. So it tells us that we have no phase shift and no vertical shift. It hasn't been moved left or right, or it hasn't been moved up or down. So now that we've got this basic information out of the way, let's go ahead and graph our brand new function and see what it looks like. So I'm going to start off with the amplitude. It's simply a 1, so it's going to be the same amplitude as our original. So 1 and -1. The period is what is changing, so rather than going between 0 and 2 pi, we want to imagine this going between 0 and 2 pi over 5. Not bad. Everything else is 0, so we don't want to move this left or right or up and down. So now let's just draw in one nice complete cycle. Oop, there we go. So that would be a nice simple graph of what sine looks like. And if you're really curious, like, hey, I think I need some more key values in here, remember the halfway point is going to be, or this, where it crosses the x-axis is the halfway point. So you can take 2 pi divided by 5, chop that in half, and that'd give you just pi over 5. If you chop pi over 5 in half again, then you'd get a couple more key values. This one would be at pi over 10, 2 pi over 10. This one would be at 3 pi over 10, and 4 pi over 10, or 2 pi over 5. So just some things you can write down. All right, let's see another example. Let's make this one a little bit more difficult. This one involves cosine. So in the back of our mind, let's get a nice basic graph for cosine. We have our amplitude of 1, a period of 2 pi, and cosine, I almost like to think of it as a U-shape. I know it's not a U-shape, it really does look like sine, but for just one period, that works out pretty good. All right, on to graphing this thing. So A, in our case, is the number that sits out in front, -1. So our amplitude is going to equal 1, but the negative tells me I should flip this over the x-axis. So I'm just going to make a little note that I need to flip it. All right, on to B. B is the value next to x. I don't see anything, so we will assume that is 1. So our period is 2 pi over 1, or just 2 pi. That means it has the same period as our basic function for cosine. Nice. C. C is the number on the inside there. That is added or subtracted. I don't have any numbers, so there is no phase shift. Moving on to D. Looks like we do have something that is added on the outside, so D, that will be our vertical shift. So everything's been moved up by 2. Okay, so we got some good information. Let's draw out this graph. I'm going to start way down here on the bottom with the vertical shift because it'll give me a sense of where I'm going to center things around. So everything's been moved up by 2. I'm going to use this dotted line to remind myself that, yep, sure enough, things have been moved up by a factor of 2. You want to think of this as your brand new x-axis when you're building things. Moving on to our amplitude. So if I go up from here 1 and down below 1, I will find the peaks and valleys of our new function. So we're at 2, up 1 would be at 3, down 1 would be at 1. So now I have the maximum and minimum. Okay, that's looking good. We don't have any phase shifts, so I'm not going back and forth. And the regular period is just 2 pi. So it'd go through one complete cycle, 2 pi. Looks like we have a note here. We need to flip the graph over. So rather than making our shape like this, we're going to actually flip that over, make it upside down. So upside down U shape, more like that. There we go. Now, last, I'd probably want to put on some key values. So halfway in between this would be 2 pi divided by 2. So there's pi. And then chop that in half again, and I get some more key values at pi over 2. 2 pi over 2, 3 pi over 2. And now I have my graph for negative cosine of x plus 2. Okay, let's keep throwing in some more values and get some more difficult graphs. Moving on, y equals 4 sine of x plus 3 pi over 2. Basic graph. 1, -1, 1 period, and 2 pi. Okay, we're going to keep that in the back of our mind. Moving on, amplitude. Looks like our amplitude is just going to be 4. And we're not worrying about flipping anything over since it is nice and positive. B. I'm going to look in front of x to see if there's any value there. We have a value of 1, so our period is just a regular period divided by this value, or 2 pi. Okay, that looks good. C. C would be whatever number this is, or you'd really want to think of it as x minus this number. That's our value of C. Since it's positive, I'm going to mark this as negative 3 pi over 2. So what I'm visualizing here is x minus a negative 3 pi over 2. That way I can get my proper value. So phase shift will come from taking our C value and dividing it by B. So negative 3 pi over 2, all of that's being divided by 1, so just negative 3 pi over 2. That tells me that rather than starting at 0 for my regular graph, I'm going to truck it over to the left, and it's actually going to start at negative 3 pi over 2. All right, let's see what else we got. D. We have our vertical shift that's up and down. I don't have any vertical shifts, so that's just 0. All right, let's see what this graph looks like. So we don't have any vertical shifts. We're not going up and down any, so I don't have to worry about that. Let's see, on to the amplitude. Amplitude is 4, so we'd mark that out as like the little maximum peak and the little minimum peak for our sine. We know that this will cycle through in exactly 2 pi, but we're going to start it back a little ways. We're going to start it back here at negative 3 pi over 2. So negative 3 pi over 2. So that's where it actually starts. Now, if that's where it starts and then it runs through a cycle, I really want to know where it should stop. And I can figure out where it stops by looking at the phase shift and just add 1 period in there. So 3 pi over 2 plus 2 pi. Or I could say 3 pi over 2 plus 4 pi over 2, which is just equal to 1 pi over 2. So it'll make 1 complete period, and then I can show it ending that 1 period at pi over 2. All right, so if I had to chop this into quarters, let's see, what would I get? So I'd get negative 2 pi over 2. Negative pi over 2, then I'd be at 0, and then pi over 2, so 1, 2, 3, 4. Okay, that works. All right, let's go ahead and draw our cycle. So this is for sine, so I'm starting at the x-axis. We will go up, reach our peak for our first little quarter there. Then we're going down, crossing the x-axis. There's our bottom peak and ending there. And of course, it does continue on, but we'll only draw just this 1 period. All right, not bad. Let's see one more example just to make sure that we have this process down. All right, this one we want to do y equals 3 cosine of 4x minus pi over 2. Basic graph, 1, negative 1, cycle of 2 pi. Cosine, I'm thinking of this U shape, so something like that. Okay, looks good. A is equal to 3, so that's our amplitude, 3. We have a number in front of x, this is 4, so we're going to use that to find our period. 2 pi divided by the absolute value of 4, or in this case just pi over 2. So it'll make 1 complete cycle in pi over 2. Okay, that's looking fine. On to C. C is pi over 2. Notice how in this case I'm not taking the negative sign because it already has the negative sign in there. So just pi over 2. So our phase shift, we will take this pi over 2. And we're going to divide it by B. So we're going to divide this by 4. So pi over 2 divided by 4, which is pi over 2 multiplied by 1/4, which is pi over 8. So we're going to start this, or we're going to move it over pi over 8. And D, this is if it's been moved up or down. This is our vertical shift. We have 0, so there is no vertical shift. All right, we have all the information we need. Let's go ahead and graph this. So we're not moving this up or down. I don't have to worry about that. Amplitude is 3, so I know it'll reach a peak at 3 and a valley at -3. That's nice. I'll make one complete cycle at pi over 2, but if I want to start drawing what these periods look like, I'm going to draw my first period starting at pi over 8. So I'm thinking of the basic shape of cosine. I need to know where I can show this period stopping. So I think of taking pi over 8, and I add one complete period to it. Our period is pi over 2. So pi over 8 plus, let's see, 4 pi over 8, 5 pi over 8. Let's put that over here at 5 pi over 8. All right, so I don't see anything else on there. So I want to think of where it starts. It reaches its minimum value halfway through. Then I'll go back up here. I can draw that nice U shape. And then that looks pretty good. And of course, it does keep going on. It's always good to emphasize that this will make even more of these periods as we continue in either direction. But we'll just draw one and understand that it does keep going. All right, it'd be nice to have some more key values in here so I could figure out where this halfway point is. I could subtract these two, so I know the distance between them is actually just pi over 2. And if I chop that in half, it'll tell me what I need to add or subtract to figure out that middle point. This middle point is at 3 pi over 8. The first guy over here is at 2 pi over 8. And what I want you to recognize is that I'm essentially going up by 1/8 pi every single time. So 1/8, 2/8, 3/8, 4/8, 5/8. And now we're good to go. All right, so there's one period of our graph for 3 cosine of 4x minus pi over 2. All right, so no matter which graph of sine or cosine you run across, just keep all of those transformations in mind and you should be good to go. Remember that it's not necessarily the numbers themselves. You might have to do a little bit of work to extract the information out from them, but then you should be good. If you'd like to see some more videos, please visit MySecretMathTutor.com.